Hello, everybody.
Hi
I'm really
guys.
so I'm really so excited to start this. I've been like waiting for this for like a week now. So we're gonna have a lot of fun tonight, and me and Vivian are going to be your teachers tonight. So yeah, we're just gonna have a great time.
Yes, hello everyone. Welcome to our live solve. Luke and I are so excited to be solving the AMC problems with you guys today. Um, we'll get started very, very soon, but for now, I'm going to go ahead and introduce my awesome co-star today. So Luke here is a super, super awesome math person from Michigan. He's a four-time Amy qualifier and an AMC 8 perfect scorer. He also represented Michigan at Math Counts Nationals, and he currently coaches a team of Math Counts students that are homeschooled, which, qualify for the state competition. He also founded Love of Math, an organization that provides high quality one-on-one tutoring for math students of all levels. But outside of math, Luke enjoys guitar, theater, basketball, cooking, and spending time with his friends and family. So everyone, please welcome Luke.
Yes, yes, thank you guys so much. All right, and Vivian over here is also a really, really cool person. Vivian is just such a great person to get to know. And Vivian is a high schooler from Ohio with a passion for math, and she loves sharing it through a lot of this live stuff here. And she loves sharing it with others as her school's Mu Alpha Theta president and has been coaching her district's math counts team for 2 years. Vivian is also a devoted Chinese classical dancer, which is so cool. And she loves to perform and is an assistant teacher at her dance studio. She enjoys connecting with friends, baking, and curating the perfect Spotify playlist in her free time. So everyone should also welcome Vivian today.
Yes. Okay. Awesome. Now, it seems like a lot of you guys have already figured it out. As you can see on our screens, we have a chat going on, which is flooding super, super quickly. But this is just how we do the chat in our live sessions. So if you go into Zoom and you choose to send your messages to chat relay, that's how your messages will show up on screen. Now, we do have moderators making sure that, the messages are like appropriate. But yeah, this is how you guys can communicate during this live solve. Now, because there are so many people, Luke and I probably won't be able to pay attention to specific messages or especially like DMs. But yeah, this is just how you guys can send messages and send your ideas or, thoughts during the live solve.
Yeah, and on that note, it would be helpful if you guys only use Chat Relay and not any of the other messaging systems like built into Zoom or anything like that to message us because we won't really have time for that kind of thing. But I think that's all the introductory things we need to do for this live solve. So, Vivian, do you want to go ahead and take the first problem for us?
All right, yeah, let's get into it. Let's see what our first problem is today. Okay, let's see. Oh, by the way, we are not working with all of the problems because unfortunately we wouldn't have time for that. So we are going to just be solving a select few of our questions. All right, so here we have Jerry who writes down the ones digit of each of the first 2025 positive squares, and we want to figure out what the sum of the first what the sum of all the numbers that Jerry wrote down is. Okay. So obviously we don't want to write down all of those numbers and calculate that by hand. So I'm going to try and look for some patterns. So I'm going to say, oh, if it's like our positive squares, if we had a 1 squared, our ones digit would be 1. If we had 2 squared, our ones digit would be 4. 3 squared, blah, 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 blah. So 3 squared would be 9. 4 squared would be 6. 5 squared, it'd be 5. 6 squared would be 6. 7 squared would be 9, 8 squared would be 4, 9 squared would be 1, 10 squared would obviously be 0, and then it will start over, right? So this is going to be the sums of our, or these are going to be our ones digit for every set of 10 numbers. And the sum from those are going to be, what, 5, 14, 20, 25, um, 40, 45. So there's 45 for every 10 numbers, okay? So I'm going to say, okay, there's 202 sets of tens, from 2020, and then we're going to multiply that by 45, and then we also have 5 extra digits. So then we're going to look at our first 5. So 1 plus 4 plus 9 plus 6 plus 5, that's going to give us, I think, 25. So then we're going to do that plus 25. Okay, and let's hope that I can do multiplication. So 202 times 45, we're gonna get, I think that, and then 808, I hope, 9090 plus 25. So that's gonna give us 9115, and that would give us answer choice number D. So let's hope that's the correct answer. And on the next slide, yes, it looks like that is correct. Awesome job, you guys. Let's turn it over to Luke for our next problem.
Yeah, I feel like that was so difficult for problem two, but hopefully it shouldn't be too much of a struggle. Okay, so now we're going to go on to the next problem. So problem four, and we have a problem that says the value of the two-digit number AB in base 7 equals the value of the two-digit number BA in base 9. All right, so let's just convert what we know about these bases into an equation. So the actual value of this number in terms of these digits is 7a plus b, and the actual value of this number is equal to 9b plus a. And what we're supposed to do is find the value of b plus a. So we can simplify this equation to 8b equals 6a divided by 2 on both sides, and we get 3a equals 4b. So now we know that b is either equal to, oops, sorry, that's a little bit too low. 3a is equal to 4b. So now we know that either b is equal to 3 and a is equal to 4, or b is equal to 6 and a is equal to 8. Yeah, I think I did that right. But that's not really going to happen because if a is equal to 8, then that number is not in base 7. So we need that b is equal to 3 and a is equal to 4, and that's going to give us 4 plus 3, or a as our final answer. And we'll check that. And indeed the answer is A. So now on to the next problem for Vivian.
Okay, yeah, nice. Let's see what the next problem is. All right. Okay, here we have a triangle ABC, and AB equals 10, AC equals 18, and angle B is 130 degrees. We're going to let O be the center of the circle containing A, B, and C, and we're trying to figure out the measure of CAO. So I'm going to draw ourselves a diagram. So we're going to start off with a circle. Okay, and then we have AB, AC. It's not gonna be the best drawing, but we'll work with it. A, B, C. That's gonna be our triangle. Okay. And okay. Oh, okay. Angle B is 130 degrees. Wait. My drawing is not the best for this. Hold on. Okay, I'm gonna say like that. I'm gonna say this is angle B. Yeah, that'll work better. Okay, this is B, and we're gonna let O be the center of the circle containing A, B, and C. And we're trying to find the measure of C, A, O. So it's like kind of that angle right there. Hopefully that works out. But yeah, for this question, let's see. I think what we can do is we can sort of make a quadrilateral, like a cyclic quadrilateral, like so. And then what we'll have is we'll be able to find, some more angles by doing some angle chasing. So for example, if I make a cyclic quadrilateral by making this A, B, C, and then making this point D, then I'll know that this angle D is going to be just 150 degrees, since the opposite angles in a cyclic quadrilateral will have to add up to 360. Yes? Okay. And so now we have that, or wait, no, opposite angles will add up to 180. And so this is going to be 50 degrees. There we go. Okay. And so then, since we know that ADC is going to be equal to that, we can find out that, we can find AOC if O is our center because they're overlooking the same arc. This AOC is going to be double whatever ADC is. And so that means AOC is going to be equal to 100 degrees, I believe. And then from there, we can find OAC because we have a isosceles triangle. And so we're going to just do 180 minus 100 divided by 2, giving us an angle of 40 degrees for CAO. So let's hope that's correct, you guys. Okay, awesome. That is the correct answer. Nice. Let's go on to the next problem. Passing it back to Luke.
Alrighty. So I feel like that was pretty difficult, and Vivian got the first geometry, which I'm glad I didn't get. So now we're going to the next one, and now we have a little bit of a story, which is kind of nice. So the problem says, Emmy says to Max, I ordered 36 Math Club sweatshirts today. Max asks, how much did each shirt cost? Emmy responds, I'll give you a hint. The total cost was A, B, B, that amount of dollars, where A and B are digits and A is not equal to 0. After a pause, Max says, that was a good price. What is A plus B? Okay, so the only thing we really know is that we bought 36 Math Club shirts, and each shirt was the same amount of dollars. It doesn't actually say that, but we can just assume it because otherwise this problem wouldn't be solvable. So let's just use this as a 5-digit number and kind of ignore the fact that it's dollars right now because it actually doesn't matter at all. So we just need to say that A, B, 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 A is a number and it's um, divisible by 36. And I added an extra L to divisible. So this is going to be equal to 1110B plus 10,001A, and this has to be divisible by 36. So the first thing I see is that this is divisible by 6 because it's divisible by 3 and 2. So that means that A has to be divisible by 6, and A actually has to equal 6 precisely, because otherwise we get something bad. So we know that we have now, sorry, oh no, we're good. Now we know that we have 1010B plus 6006, and this has to be divisible by 36. So now what we're going to do is take the entire thing mod 36, and then we should be able to figure out what B will equal in this case. So mod 36, 6006 is equal to, oh my goodness, this is not easy. 2406, then multiply 36 by subtract 216 0, and then 246, then subtract 216. So this is equal to 30 mod 36. So we need this to equal 6 mod 36. Okay, so let's take another slide here. Oh, yes. So now we need 1111B to equal 6 mod 36. So this means that we need to figure out what this is mod 36. And this mod 36 is going to be equal to, I'll just do all this math, 20. 20B is equal to 6 mod 36. And now I'll break it up into 4 and 9 mod 4. B is equal to, hold on, wait, did I do this right? 1100 and, oh, I did that wrong. 30B, okay. 30B is equal to 6 mod 36. So we're going to need B to equal something mod 6, or actually some small digit. So I think we can just try things out, right? And when we start with 30, actually, we're going to separate one more from mod 36 every time we do it. So we're going to need B to equal 5, I believe, because that way we can decrease, because the difference between 6 and 36 is 30. Basically, there's a lot of ways to figure this out, but B is equal to 5, I believe, and we'll just check it just to make sure. 150 and subtract 144, and indeed B is equal to 5, and we got for D is equal to 6. So A is equal to 6. 6 plus 5 is going to equal our final answer of 11, and I'm not sure I did this the fastest way, but hopefully that is our correct answer. And indeed we do get 11. So now back to Vivian for the next one.
Okay, yeah, nice job. Let's see what our next problem is. Okay, lots of words. Let's work this problem out together, you guys. Okay, on Monday, 6 students went to the tutoring center at the same time, and each one was randomly assigned to one of the 6 tutors. Now, okay, on Tuesday, the same 6 students showed up and the same six tutors were on duty, and the students were again randomly assigned to the tutors. Now we're trying to find the probability that exactly two students met with the same tutor on both Monday and Tuesday. Okay, you guys, let's think about this problem. So I feel like, okay, we have our six students and our six tutors. I'm just gonna write S and T. And okay, I think one way we could think about this is we could first take care of the two students that have the same tutor, and then we could figure out how many ways there are for the remaining four students to not get this tutor that they had before. So if we first take our two, like we're gonna first choose our two students that get the same tutor. So I'm gonna say that's gonna be like a six choose two. And then we have to figure out how many ways we can figure out the number of ways those other four people can get the tutors that they didn't have, if you know what I mean. Okay, so in order for them to get the tutors that they didn't have, like because we want exactly two of the students to have the same tutor, they would have to, like, how do I say this? Like, in order for them to get the tutors that they didn't have, they would have to either get one of the other three tutors. So there's three options for the other people. So let's say our remaining students, so let's say we have our A, B, C, D, E, F, G, right? Or A, B, C, D, E, F, okay? And A and B are the people that got the tutors that they had before. So now we have C, and C doesn't want the tutor that they had before. So there's going to be three options for them. There's like tutor one, tutor two, 2, 3, and 4. And let's say they had tutor 3, and so there's only three options that they want. So that's going to be a 3. And then for the remaining person, let's say it's D, and then E, and then F. Of the remaining tutors for them to also not get the one that they want. How could we move forward with this? Luke, do you have any ideas?
Yeah, so I think there's like a way to do it where you like there's like a formula thingy for like ordering things where they're not in the same thing, but I didn't really like remember any of that at all. So you can just do like a sort of casework thingy, and that's what I'll show you guys. So
Okay, yeah, let's
basically,
bash it out.
yeah, you have like these four thingies right here, and then what you do is you like look at the first person, or not necessarily the first person, but the person who's going to take the place of C first, and you have three options for that, and they're all symmetric, so they're going to produce the same amount of total outcomes. So we have three options for that because we could choose the D, the E, or the F. Any of those would work. So let's just say we chose the D because the other ones are going to be exactly the same as the other one. So now we have three different places where we can put the C. And if we put the C under the E or the F, then that is going to be similar to each other. So we have two cases, when the C is put under the D and when the C is put under the E or the F. So when the C is put under the D, then the E and the F have to switch spots, otherwise they're the same one. And when the C is put under the E or the F, we have the letters F and, which is the other one we have left? F and E. Okay, we have F and E left, and we have to switch the one, so like the F can't be where it was before, so it has to go over here, so we only have one option for that. So we have 3 times 2 plus 1 plus 1 options. So that's 3 times 4 total options, and then we get 12. And we can multiply that by 15, so 15 times 12, and that's going to equal 180. And total number of options is 720, right? Because that's going to be 6 factorial. And 180 over 720 is equal to 1 over 4. So I think the answer is C. Is this a good, Vivian?
Let's take a look. I'm not sure. Oh, okay. It looks like our answer
Wait,
is okay, it's 3 over 16. All right, guys. Do you guys have any ideas in the chat? Luca and I have never seen these problems before, so we're solving them live for the live solve. But if you guys have any thoughts to help us out with this problem, we would love to hear from you guys.
wait, you said that you like you said that to me like knowingly, sounding like you knew that I was gonna get the wrong answer and you knew how to do it.
No, because I wasn't sure either, because I wasn't too sure what you were doing. So I'm like, let's take a look. Okay. Okay.
Dude, he said not he made the mistake on purpose, bro. They're overestimating us.
You guys. Okay, let's try and think through this problem again. Yeah, I feel like we're overcounting some things. So also, okay, yeah. Let's work
Oh,
through
I'm
this
so
on a
dumb,
blank
dude.
thing. Oh,
Oh, sorry.
looks like he found it out.
I mean, it does look like I made it on purpose. That was actually the dumbest thing. Okay, so basically, like when you put the C under the D, then you also just have to switch the F into E. So we don't get 2 here, we get 1 here. So that's 3 times 3. And then instead of 12, we have 9. So 15 times 9 over 720 is going to be 3 over 16. Sorry, that was really bad.
No worry,
Okay.
no worry.
I think that should be the correct answer. No, 3 over 16. All
Okay.
right.
Yeah. Definitely a pretty difficult problem, but it's totally okay. Let's move on to the next one.
Yeah.
Wait, is it my
Okay.
turn or your turn? Is it you?
Well, it's my turn next. I want to get this one,
Okay.
bro.
Okay, you got this. You got
Don't
this,
steal
Luke.
my problems from me.
Yeah. You got this.
All right. The figure below shows an equilateral triangle, a rhombus with a 60-degree angle, and a regular hexagon. Each of them containing some mutually tangent congruent disks. Let T, R, and H respectively denote the ratio in each case of the total area of the disks to the area of the enclosing pentagon. Which of the following is true? T is greater equals H equals R. T, okay, a bunch of different thingies. Okay, so I'm going to draw some thingy things because that's what I want to do. I'm going to draw that line, and then I'm going to draw this line, and this line. Okay, so for the hexagon, what you kind of notice is that it's made up of a bunch of things like this. So it's made up of a bunch of this. So like whatever this ratio is, I don't really know what it is, but I don't really care to figure it out right now, so I'm not going to figure it out. And then this rhombus thingy is made up of a bunch of this as well. So that means right now that we already know that rhombus is equal to hexagon. And let's just see how many answer choices we can eliminate just based off this. So we can eliminate this one, and this one. So now we're down to 2. Either triangle is equal to H is equal to R, or H is equal to R is greater than T. So this one is not made up of a bunch of this. What it's made up of is things with more area than this. And if this were the case, answer A, then we would have to like somehow break this triangle down into like this, which is just really not going to. And when you think about it, if all these 3 circles are tangent to each other, like if you made the circles infinitely small, they would cover the area of the entire triangle. So when we're making one circle, which would be the same area as this one and this one, the same ratio of areas, if we're changing that to 3 circles, then that's going to increase that ratio. So our final answer should be C. And checking our answer, we do indeed get C. So now back to Vivian for the next one.
Okay, yeah. Let's go on to the next problem. Okay, let's take a look. Oh my gosh, it's a geometry problem. No, not
It's
another
like
one.
kind of algebra too, you know?
Okay, yeah. All right, let's see. So here we have that the altitude for the hypotenuse of a 30, 60, 90 triangle is divided into 2 segments of lengths x is less than y by the median to the shortest side of the triangle, and we're trying to find the ratio of x to x plus y. So I'm gonna make a new slide just so we have more space, and I'm gonna draw this out because we love drawing pictures, you guys. Okay, so we're gonna draw our 30, 60, 90 triangle, or attempt to. Oh, never mind, that's really ugly, but it's okay. Which side is the long one? Okay, it doesn't say. So I'm just going to say that this is A, B, C. This is our 30, 60, 90. And then we have the altitude from the hypotenuse right there. And then, let's see, it's divided into 2 segments by the median to the shortest side of the triangle. So we have our median here, something like that. Okay, and then x is less than y, so this is x and this is y, and we're trying to find the ratio of x to x plus y. Okay, so let's take a look. I think with this, we can probably... Wait, Luke, am I remembering this right? Isn't there like... Is it... There's that one theorem. Is it Menelaus?
Menelaus.
or I don't know how to say the theorem, where it's like where they intersect the different points, the ratio is going to be one.
Oh yeah, yeah, like
Wait, I'm
max
gonna try
points.
using that, you guys. I'm gonna try
Oh yeah,
using
that's
that.
actually smart. That's pretty smart.
Wait, I feel like we might be able to use this in this
No,
problem.
yeah,
So I
you're right.
think we can say, should I label some more points? A, B, C. I'm gonna say this is D. I'm gonna say this is E, and I'm gonna say this is F, okay? And so we're gonna say, I think, DE over, let me think, like BE should be equal, or no, not equal, times, I think, BF over, is it BF over FC times should be CA over DA equals 1. Is that the theorem? I really hope so.
Um, well, do you? That's not necessarily how I use it, but I think that should be right.
Okay, but anyways, we can set BF equal to CF since, this is the bisector. And then from there, we have AC over AD equals AC over AB times AB over, this should be AD. So then we have 2 over root 3 times 2 over root 3. Like if, yeah, this is our 2 root 3, this is 1, 1, blah, 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 equals 4 over 3. So then we have, I think, ED over EB is our, mm, oh, yes, AD. This should be AD over our AC, I believe. And that will be our 3/4. And so that means our X over Y is going to be our ED over EB. So that should be 3 over 3 plus 4, or 3 over 7. Okay. Oops, I've been writing on my face, but let's see. Is 3 over 7 an answer choice? Okay, it is an answer choice. Is that the correct answer? That's the question, though. Okay, it looks like we got there.
Yay, that was great. So the way I do it is like mass points, and yeah, that's like another interpretation. Have you like you've heard of mass points, right?
Yeah, yeah, yeah.
Yeah, that's how I would do it, but I somehow I goofed up something somewhere and I couldn't figure out how to finish the problem. But anyways, yeah, that was a really great solution, Vivian. Okay, and now we're going on to the next problem, and this one looks like quite a doozy. So the sum from k equals 1 to infinity, 1 over k cubed plus 6k squared plus 8k can be expressed as a over b, where a and b are relatively prime positive integers. What is a plus b? Okay, so the first thing I see is that I really want to factor that just because, like, I really want to factor it. So we have k times k plus 2 plus k times k plus 4. Okay, and I think what's going to happen here is we're going to have some sort of, like, telescoping thing, right? Where when you, like, add or subtract something, it's going to, like, lead to something else. Okay, that was really vague. But the first thing I noticed is that these numbers right here are all they're like consecutive even numbers. So whenever I see a problem like this, I'm just gonna do the first couple of numbers and see what happens, right? So we have 1 over 15. The next one is 1 over 48. The next one is 1 over, oh my word, I'm so bad at math. Uh, 105, and the next one is 1 over 864, 32, 192, I believe, 192. Okay, I'm just going to see if there's anything that we can accomplish by doing this that will be helpful to us at all. Okay, well, actually, if you think about it, like we should pair this number and this number together because they're going to have the same factors, and we should pair this number and this number together. So this is going to be 8 over 105, and this other one is going to be Let's see here. 48 times 4, I believe. Wait, hold on. I can't do the simple math of this problem. 2 times 4 times 6 equals 48. 4 times 6 times 8. Okay, yeah. So that is going to be 5 over 192. Okay, so that didn't really get us anywhere, but I think I see what we're going to try and do with this problem, right? So we have k plus 2, and k plus 4. So what we're going to want to do is we're going to want to relate like the first, third, fifth, and seven numbers to each other in some way because they have shared factors, and then we're going to relate the other numbers to themselves and see what happens from there. And I'm going to start on a new slide now because I think we know the problem statement. So let's look at this. K times k plus 2 times k plus 4. Okay, and then if we add this to... Oh, hold on. Okay, never mind. I'm going to change our approach. Okay, so what I'm going to do is I'm going to add these two fractions together, and what's going to happen is... Maybe this isn't a good idea, but... what's going to happen is we're going to have a lot of like terms that we want, right? And we might have some terms that we don't want, but I think this is going to be pretty good, hopefully. Okay. So k cubed plus 6k squared plus 8k over all of that. K all the way times k plus 5. And then you add this to... Oh, sorry, that was the other fraction. I'll do the other one now. So k cubed plus 9k plus 15 plus 3 plus 5, which is going to be 23k. Oh, sorry, this is k squared. And then plus a 15 at the end. Okay, let's add this all together and see what we get. And it looks pretty unfruitful, but who knows? K cubed plus 15k squared plus 31k plus 15. Are there any nice factorizations of this? Probably not, but... Vivian, do you have anything you see so far in the problem?
I've been doing the problem a little bit differently, especially with the help of the chat. I noticed that they pointed out that we could use partial fraction decomp, and so the really annoying looking fraction at the beginning can be rewritten as something a little bit more like this, where we factor out an 8, and then on the bottom, or then on the inside, we have 1 over k minus 2 over k plus 2 plus 1 over k plus 4, and I think if I'm doing my math correctly, we can then rewrite that as this plus 4 minus 1 over k plus 2, because then we can rewrite this more and more and more. I feel like, and then I feel like this is going to give us to something where we have things that cancel out, like a telescoping sum, if that makes sense. So,
Yes.
I don't know. What should we do, guys?
Okay, yeah. I think that makes sense for now. So, I kind of want to just verify that that is the case because, like, we need to be at least, like somewhat on our own. Okay, so yeah, that's another way to approach a problem, I suppose. So 1 over k cubed plus 6k squared. I kind of forgot that like partial fraction decomposition like even exists, but
Yeah.
a over k plus b over k plus 2 plus c over k plus 4. Okay, so then k squared. Okay, a has a k squared term. So for the a term, we have a k squared term plus 6k squared plus 8. Sorry, not k squared. 6k, not the squared. For the b term, we have k squared plus 4k. And for the c term, we have k squared plus 2k. So a plus b plus c equals 0. 6a plus 4b plus 2c is equal to 0 as well. And then 8 is what we have over here. So in order to do that, we're going to have to um, multiply this entire thing by 8 on this side. So we're going to have to multiply our sum by 8, and then we're going to have to divide by 8 again. So 8 times our sum, and then is equal to this partial fraction decomposition. So then a plus b plus c equals 0. Subtracting 2, we get 2a plus b is equal to 0. And this gives b is equal to negative 2a. Let's just let a equals 1, and then b is equal to negative 2, and c is equal to 1, which is what we got before. So we have 1 over k, negative 2 over k plus 2, and 1 over k plus 4. And you could choose like a bigger number for a, but like it doesn't really matter right now. Okay, so now, oh, oops, nope, no one saw that. Okay, and now we have our thingy thing. So let's just say like 8 times our sum is going to be equal to the sum of 1 over k minus 1 over k plus 2 plus the sum of 1 over k plus 4 minus 1 over k plus 2. So what's going to happen is we're going to have a bunch of these things cancel out, but let's just start with our first one. So we have 1 over 1 minus 1 over 3, 1 over, that's a perfect 3, isn't it? 1 over 2 minus 1 over 4, 3. Okay, and then 1 over 3 minus 1 over 5, and then these are going to start canceling out. And everything is going to cancel out except for this 1 and this 1 over 2. All right, now go over here, and we have negative 1 over 3 plus 1 over 5, negative 1 over 4 plus 1 over 6, negative 1 over 5 plus 1 over 7. And all these things are going to cross out, except for this one and this one. And add those together, and you get negative 5 over 12. Oh my goodness, I did not do that right. Negative 7 over 12. So negative 7 over 12, and then we have also the other two fractions. So that's going to be 3 over 2 minus 7 over 12, and that is equal to 11 over 12. So 11 over 12, and then we have to divide by 8, and that's going to give us 11 over 96. So our final answer, summing a and b together, because that's what it is, summing the denominator and the numerator, we get a final of 107. So we had a little suggestion for what to do there, but I think we find our final answer, and yeah, indeed, it is 107. So now back to Vivian for the next one.
Okay, nice job. That was definitely a pretty tricky problem with all of those fractions and sums, but we still made it through. So let's take a look at the next problem. Oh my gosh, why is it geometry again? Okay, it's okay, you guys. We'll work
We're
through
fine.
this.
We're fine.
Okay, four congruent semicircles are inscribed in a square of length 1 so that their diameters are on the sides of the square. One endpoint of each diameter is at a vertex of the square. Okay, that makes sense. And adjacent semicircles are tangent to each other. A small circle is centered at the center of the square and is tangent to each of the four semicircles as shown. Okay, I'm just going to draw some things. Semicircles as shown on the right. The diameter of the small circle can be written as blah 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 blah, where a, b, c, and d are integers. What is a plus b plus c plus d? Okay. So, oh wait, yeah. Okay, that's what I was thinking. Okay, since we have our tangents, we can obviously draw some perpendicular lines, and then from all the centers of the semicircles, they line up really nicely. So I want to draw this here, and boom, 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 and then this here, and this here, and this here, and this here. Okay. And then I feel like we can label the radius of one of the bigger semicircles. I'm going to say that's like x. Okay. And then this is also going to be x. So that means this long side right here, this is like, this one's also x. And then this one is, this is a 1, 2, root 3 triangle. So this is x over 3, but it's also the big side minus x. So this equals 1 minus x. So Yeah. So we have 1 minus x, because the whole side length is going to be equal to 1, is equal to our x root 3 from our 30, 60, 90 triangle. So from here, we can say, oh, we can isolate this. So we have x equals to 1 minus x over root 3. And we can just make this a little bit nicer. Actually, no. Wait. Sorry. Root 3. Okay, so that means x root 3 plus x equals 1. So that means x equals 1 over 1 plus root 3. So x is equal to root 3 minus 1 over, yeah. Okay, and then let's see. We need to find the radius of our smaller circle. So in order to get the radius of our smaller circle, we can just work with this part over here. Do, 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 do. And then let's see. I'm going to say our radius of our small circle, we're going to say that's y, and then we're going to say that this area right here plus our x is going to be equal to the diagonal of the entire bigger box thing. So that's going to mean that our x plus y is going to be equal to, if our side length is 2x, that means our diagonal is going to be equal to x 2x root 2. So that means we just x plus y is equal to x root 2. So that means y is going to be equal to x root 2 minus x. So, oh my gosh, I'm running out of space. So y is equal to x root 2 minus x. So y is equal to x times root 2 minus 1. Am I doing that right so far? Okay. Yes, I think so. Yes. Is that right? Okay, yeah. And then from here, if we go back to the problem, that can be written as root a plus b times root c plus d. So this is equal to root a plus, is it c or b? Okay, b times, what is it? Root c plus d. And we are trying to figure out a, b, c, and d as our integers. Okay. Then from here, what can we do in order to get this into the form that we want it? Any ideas, Luke?
Hold on 1 second. I wasn't doing exactly what you're doing, so I'm gonna
Oh,
do
okay,
that.
my bad.
No, but yeah. I think the radius is root 3 over root 3 minus 1 over 2. And then
Should we just
we,
substitute it in?
we should multiply this by root 2 minus 1. So, like, we want, like, this is really close to our form, right? Like, this is the answer that you got, right? Root 3 minus 1 over
Wait,
2.
yeah, root 3 minus 1 over 2 times root 2 minus 1. So this is our thing over here. Oh, I forgot to substitute. That's why. Okay. Root 3 minus 1 times root 2 minus 1. And that's equal to our
Oh!
mini radius. Yes. Okay. So that means 2 times our radius. So 2y is going to be equal to root 3 minus 1 times root 2 minus 1. Yes?
Yes, yes,
So,
yes.
wait. Oh yes, it's asking for the diameter. Oh my gosh, that's perfect. 2y is our diameter.
Yeah.
Yay! Okay, so that means A is 3, B is -1, C is 2, D is -1. And that means our sum is going to be equal. This cancels out, that cancels out. So our sum is just 3. Please tell me that's an answer choice.
Yes.
Okay, is our sum 3? Let's see. Is the answer 3? Oh, it is 3. Oh my gosh. Yay, good job, guys.
Let's go. Okay, so like we were actually like confused for very different reasons because I like saw that we had all of this right here. But like the reason I was confused is because I thought it said radius and not diameter, and I was like, bro, it's like divided by two. Like, what are we doing?
Wait,
But
yeah, I was like, I feel
you
like
got
I
the final
found.
answer.
No, yeah, I was like, I swear I have found X already, but I don't know what to do. Oh my gosh, I was like, I can substitute it in. Okay, that's perfect. Okay, on to the next problem.
Wait, this is mine, correct?
Yes,
Okay,
I
okay.
think.
Yay, combo. I feel like we haven't had very much combo. All right.
Oh yeah.
Each of 9 squares in a 3 by 3 grid is to be colored red, blue, or yellow in such a way that each red square shares an edge with at least one blue square. Each blue square shares an edge with at least one yellow square, and each yellow square shares an edge with at least one red square. Colorings can be obtained from one another by reflections, by rotations and or reflections, or to be considered the same. How many different colorings are possible? Okay, there's 2 things I'm going to notice here. First of all, the colors red, blue, and yellow are symmetrical. So like none of them has like a different role than the other one. They all have to be touched by one, and then they have to be touching the other, and it's like a kind of a loop, right? So our loop says that red shares an edge with at least one blue square. Red must share an edge with blue. Blue must share an edge with yellow, I believe. And yellow must share an edge with red. All right, and then the second thing I'm going to notice here is that our answer choices are really, really small. So it seems kind of like you could list out all of the different possibilities and then like rotate for the colors because you're always going to have to multiply by 3 because unless everything is no, you're going to have to multiply by 3 because there's going to be some color in the middle. And yeah, so that's really interesting that we have red, yellow, and blue as very symmetrical because that means we can put any of them in the middle. So let's just say we have red in the middle, and then once we do that, we're going to multiply by 4 at the end. So since we have to share an edge, that means that let's just put a blue here, for example, okay? Because we must have a blue in one of the things. And I see Vivian did the exact same thing. So we're together on this one. Okay, so first of all, I see a way that we can just finish the thing and give us 3 possibilities. So I'm going to go ahead and do that because our answer choices, like I said, are low. And if I see any solutions, then that is obvious. Oh my goodness, I'm so dumb. That's not a solution. What am I thinking? Okay, that's not a solution. All right. So blue shares an edge with at least one yellow square. So that means that there has to be either a yellow square in this little thing or in this little thing. So without loss of generality, oh my goodness, I haven't done things like this in such a long time. Without loss of generality, let's say that y is in this one. Okay, so now y, wait, hold on. Y needs to share an edge with a red one. Okay, yeah, so let's say that we put it in that one, and then that means that our red has to be here, okay? And we could have done the other side, so assuming that this is not going to be a yellow over here, the other thing is not going to be a yellow, then that means that we have 2 options for this, so however many results we get from this case, we can multiply by 2, and then we'll also multiply that by 3 because we have the r in the middle right here, so multiply by 3, multiply by 2. And that means that this has to be a blue up here. Okay, and it looks like we're literally just going to like go around the circle and do all the things, right? Blue. And then next to the blue needs to be a yellow. Now we need a red over here, and then we need a blue, and then the one we need next to the blue is the yellow, right? There's no other way for us to fill that in, right? Vivian, do you think I'm right with this one?
Hold on. Okay, because I had the same idea where we had our red start in the center, and then obviously each red needs a blue, so we're just gonna choose one of the ones next to it to give it a blue, and
Yeah.
then every blue needs a yellow, but also every yellow needs a red. So that means we have to have a red here. Yes, that's what you have. Okay, cool. And then every red needs at least one blue. So that means this red needs to have a blue here, and then every blue needs a yellow. So then everything goes there. I feel like we can only fill up
Oh,
to this much, and then the rest of it can be there's like different possibilities, and that's where our multiples are going to come from.
hold on. I think I see it. I think I see it. So, like, we need to use the fact that, like, the red is middle. So that means that, like,
Yeah.
any, blue. Wait, hold on. No, any yellow can be in any of those squares and not have like one next to it. So, oh yeah, okay, I messed up right.
Like, I
Right.
don't think this one has to be a red yet. Like,
Yeah, yeah, yeah.
I think we have six determined right now, and then these ones can change a little bit.
Yeah,
Like,
yeah,
there's
yeah,
multiple
yeah, yeah.
possibilities for this.
Yeah, you're right, you're right, you're right. Yeah. So this one doesn't have to be a red, and if it is a red, actually, there's no solutions, right? Because we just proved that. Because if this is a red right here, then that means that this, uh, the one right next to it's going to be a blue, and the bottom one is going to be yellow, and that doesn't work, right? Do you think that's correct?
Uh, maybe.
I, be- I think I believe in myself for this one.
Yeah, yeah, yeah. I
Okay.
believe you too.
Okay, so then that means that what we're going to have to do is put a blue here instead of the red. And then we're going to have to put a red here, I think. Right? Okay, I think this is our only solution. Let's just make sure everything works. The yellow has to be next to a red. Blue has to be next to a yellow. Yellow has to be red. Red has to be blue. Red has to be blue. Red has to be blue. Yellow has to be blue. Blue has to be red. And this is really nice, I think. So I'm pretty sure this is how it works. So now, how many different ways are there to do it? So we have three different options for that color in this middle thingy. We have three options for it, and then we could have it horizontally or we could have it vertically, right? So 3 times 2. And then for this YBY thing on the bottom and the top, we can either have it like be YBY or BYB. So there's two different options for that. So 3 times 2 times 2 is 12. But hopefully that's our answer. Yeah, I'm just going to check it. I really hope it's the answer, but yay, let's go. All right.
Nice. Okay. All right, moving on to the next problem. We are getting towards the end, and these problems are getting harder, you guys. Okay, now we have a seven-digit positive integer, which is chosen at random, and we want to find the probability that the number is divisible at 11, given that the sum of its digits is 61. Wait, okay. I feel like this 61 is really important, you guys, because if it's seven digits, that means the maximum like the max it can be is not like all nines, 9999999, and that's 63. So that means we're going to have like we have all of our nines and then like two of the digits are like one less, I think.
Or one digit is two
Or
less.
one of them is two less, aka it would be 7. Is that would that work? Because if it's divisible by 11, that means if we take the odds and the evens and the odds, so we go like doon 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 doon. Wait. Yeah, and then we go like doon 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 doon. What? Yeah, and we go like that. When we subtract them, they have to have a difference that's like a multiple of 11. So it's like either 11 or 0, I think. Yeah. So I feel like let's just say for now that we're only gonna have nines and eights. So there's gonna be two of our spots that have a digit that's like one less, and we have to take two of those. So we would have to get. Okay. We need to like pick two of these digits that are going to be one less than the rest of them. So I think we can just say that there's going to be like what, 7 choose 2? And what is that? That's 7 times 6 over 2, so that's like 21 ways. And so there's going to be how many different numbers? What is the probability that the number is divisible by 11, given that the sum is, okay, is 61. Okay, and then, yeah, so if it's supposed to be a multiple 11, then that means when we take the evens and the odds, that the difference is going to be 11 or 0. And so in order to choose those, it's going to have to either be the second, the fourth, or the sixth slots. So that means there's going to be, I think, 6 ways to do it. So it should be like, okay, we're not using this 21 because there'll be 28 in total. Yes? And then
Yeah.
6 over that. So 6 over 28, I think. Is that what you did, Luke?
Yes.
Because
And I actually have to confess I've seen this problem before, so
oh. Oh, okay. Thanks, Luke, I guess. Oh, wait, yes. Okay, so there's 21 that are the that are like nines and eights, and then there's seven more from the just there's a nines and one seven. So that's 28 in total. So there's 28 total, and then we have our 6 over our 28. So that's going to give us 3 over 14. Yes.
Yes. And I feel
Okay,
like
is that
that
correct?
problem, yes,
Luke,
that is
since you've
correct.
seen it before?
I did it the other day in my head when I was like at church. So, all
Hmm.
right. Next problem. I think that wasn't too difficult. So hopefully they just get easier as you get farther
Yeah,
along. Who knows?
maybe.
Yeah. But the 24th problem says a frog hops along the number line according to the following rules. It starts at 0. If it is at 0, then it moves to 1 with probability 1 half, and it disappears with probability 1 half. Okay, let's just start with some number thingies, and then we'll read the rest of the rules because I don't like being overwhelmed by information. Okay. 1, 2, 3, 4, 5, 6, 7. That's when we'll stop. Okay. If it starts at 0, then it moves to 1 with probability 1 half, and it disappears with probability 1 half. For n equals 1, 2, or 3, if it is at n, then it moves to n plus 1 with probability 1 fourth. Okay, this looks like a bunch of states, honestly. 1 half, and then 1 fourth, 1 fourth. Oh, sorry. No, I'm saying this wrong. If it's at n, oh my goodness, it doesn't even go to 5, 6, or 7. What am I doing? Okay. If it is at n, then it has a probability of going forward 1 fourth and going back 1 fourth. And it has a 1 half probability of disappearing. What is probability that a reach is 4? Okay, so this is really just states. So we're going to set up a state, state for 0, state for 1, state for 2, state for 3, state for 4, and our answer to the problem is going to be the state of 0. Okay, so state 0 is equal to um, state 1 over 2 because there's a 1 half chance that it disappears. State 1 is equal to state, hold on, state 0 plus state 2 over 4. And then it's also just the same thing for all the rest of them. State 2 equals state 3 plus state 1 over 4. And state 3 is equal to 1 plus state 2 over 4. And now we just have to solve this four variable system of equations. Hopefully it shouldn't be that bad, but I don't think anyone likes doing things like this, honestly. So, um, especially when I have to write everything out. So, oh, no, no one saw that. Okay. um, S0 is equal to S1 over 2. S1. I'm going to rewrite all of them because I need more space. So, S0. And I think I'm going to solve it this way first, so I'm not going to write down the rest of the equations. So S1 is now equal to S1 over 8, because that's what S0 over 4 is, plus S2 over 4. So S1 is equal to 2S2 over 7. So I did a little bit of that in my head, but I'm pretty sure that should be right. S2 is equal to S1 plus S3 over 4. And that means that I'm going to try and be really impressive and do all of this in my head. Never mind. I'm not going to try and do that. S2 is equal to 7S3 over 26. I think. All right, I'll like make sure. One more second in my head. It's just a lot of like algebra that I didn't really want to write out, you know? So 14 over 13. And multiply that by that. And yeah, this should be right. Did you get this? Oh wait, maybe you're not doing it.
Oh wait, I've like done this problem before, so I wanted to let you do it.
Oh, okay, okay, okay. Am I getting the right numbers? Do you know?
Um, some of them look familiar, yeah.
Some of them look familiar. How reassuring. All right. So, then this last one, S3 is equal to S. Okay, yep. Substituting what we got in for S3 in, then we get 7S3 over 26. And that should be 7S3 over 104. So that's going to be equal to 97 S3 over 104 is equal to 1 over 4. All right. That means that S3 is equal to 26 over 97. And hopefully everything should work now. Oh yes, it looks like everything works out well. And like if you just like look at the cascade of fractions, then your answer is 1 over 97. Yeah, I'm not gonna really show how you did that, but basically like you go through this one again, then through this one, and then you go through this one again, and then your final answer is 1 over 197. So the answer is indeed 1 over 97. So I went through that one like a little bit fast, I suppose, and like didn't go through all my math and steps. But basically, you set up all of the states, and then you have four variables, four equations, and you go from there, and that's how you solve the problem. All right, on to the next one.
There's another problem. Oh my gosh.
Oh,
Oh
it's
my gosh, dang it.
geometry.
Why am I getting all the geometry problems? Why do they do this to me? And it's all the
Oh,
problems I haven't. Oh my gosh.
dude, this
Okay.
is like the wait, this is like the you know like the Instagram reels where they have like the TV thingy like going around the thing and like it goes in the corner.
Oh yes, or it like
That's what it
bounces the
is. That's what this
logo.
is, bro. That's what this
Okay.
is.
Okay, you guys, I'm probably gonna need help with this problem again, but it's okay. Square ABCD has side lengths of 4. Points P and Q lie on AD and CD, respectively, with AP is equal to 8 over 5 and DQ is equal to 10 over 3. A path begins along the segment from P to Q and continues by reflecting against the sides of ABCD with congruent incoming and outgoing angles. If the path hits a vertex of the square, it terminates, otherwise it continues forever. At which vertex does the path terminate? Okay. Let's think about this, guys. Okay, so I'm just gonna, can we like, can I like use like coordinate batch or something?
No, wait.
Like, can I like set them to coordinates or something? You
I
know?
mean, I think you could, but wait. Sorry if I'm like stealing a little bit of your problem, but like the thing
No,
that they
go
always
ahead, go ahead.
the thing that they always do when like things reflect is they always do like the line where like they just like rotate it a bunch of times, so it's really just like a straight line.
Oh, you're so right.
And then like when it hits a coordinate, it's gonna be like hitting a certain point in the coordinate plane, you know? So
Yes.
like you're just gonna like find the equation of a line, I
Mm-hmm.
think, and then you're gonna find when it
Yeah.
hits like something that's divisible by four.
Yeah.
The both things are divisible by four,
Yeah.
and then you're gonna have to figure out which one that is. Which I don't really know how that would work, but yeah, I think that's kind of how you do the problem.
Okay. So we're doing the problem.
Dude, it's not even geometry. Like honestly, let's be real.
Okay, fine. Okay, so yes. All right. We're gonna say okay, AP is equal to 8 over 5, got it. And then DQ is equal to 10 over 3. Yes, okay, that's what you did. Okay, wait, that's 10. Wait. You know, I'm gonna stop looking at my screen because Luke is just on my screen and I don't know. Okay. So, yes, let's get the equation of a line. Mm, just 25 is 18x. Wait, negative 18. Wait, 18x plus 40. So y is equal to 18 over 25. X plus 40 over 5. So y is equal to...
Wait,
Wait, what?
I oh, I'm so stupid. Okay, you're right.
Wait, what? Huh? Am I doing this wrong?
No, I think you're doing this right. You're doing this right. I think.
Because I feel like I'm doing it wrong. Because we want it to pass through... Okay, yeah, because the side lengths are 4.
No, yeah, you got the right equation. I think. Wait, except
Yeah?
for it should just the y-intercept should be 8 over 5 now because like the p is
Oh,
8 over
yeah,
5.
yeah, 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 yeah,
Okay, yeah.
yeah.
So then that should be right
Okay.
there.
Because like if we were to draw this like thing like super super big, right? It'd be like that or something. Wait, no. Like
Sure.
that. like
Yes,
that. And it's like
yes.
boom, 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 boom. Something like that. Is that what
Yeah,
we're
yeah,
doing?
yeah, yeah,
Yes.
yeah, yeah, yeah. Great.
Okay.
Wait, no, we're like kind of close to the answer.
Okay. So from here, what are we gonna do? Okay, we have a equation, and then from here, we are going to say that. Let's think. I don't like these fractions. I'm gonna keep it in this form actually. I'm gonna just keep my whole numbers. Okay, so we want
Yeah,
it to pass through the side lengths are four. So we want it to pass through something that's like gonna be like a multiple of four and four. So I'm gonna say it's like A and B. Yeah, so like our X's are gonna be like 4A and like our Y is gonna be like a 4B. Does that make sense? Maybe?
sure.
Like
Yeah.
25B minus 18A. From there.
Okay, yeah.
And then because we have that thing, it should be 10. Yes, 25 times that plus that. Okay, yep. Okay. And then we're gonna have our B, and then we have our. Oh my gosh, guys, I can't do this. It's too late. It's 9 p.m. It's 9:30 p.m. I want to go to bed. Oh, thank you for the encouragement, you guys.
Okay, I think I got it. B
Right?
equals four. B equals four. A equals five. Yes, that's correct. I believe.
So that means so X is equal to 20, right? And Y is 16.
Yeah. Okay, yeah. And
And
now we just
so
have to
the
figure out which
vertex.
thingy that is. Wait, that's really hard. That's not easy.
What if we
Hold
just
on.
draw a picture?
Yeah, that's what we're gonna have to do. Wait, this is the hardest part of the problem. I didn't know that there's a harder part of the
Okay.
problem.
So we have A, B, C, D. A, B, C, D, right? Like that. And it's going like, pshoo, right? And it's like, duh. Whoa, that was a good line. Okay, wait, like that. It's like, pshoo, dun 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 dun, dun 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 dun, dun 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 dun. I have no idea if I'm getting this correct.
No,
Dun
no,
dun
no.
dun
Yeah.
dun, dun 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 dun. Wait, I think I made those. No, it's like boom, 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 ba-doom,
I like your sound effects.
ba-doom. Because we have four and five, right? So four and five. Yes,
Yes.
yes. A, B, C, D. Wait, it's this way. Wait, is it just B? Wait, I think I drew it backwards. Because if we go from here and then it goes up this way, right?
Yeah, but wait. No, but
Wait, did I do?
you have to count like the amount of people that the amount of times like it hits a wall, right?
Yeah. So one, two,
I think it's seven.
3, 4, 5, 6.
Seven.
Wait, 7.
Yeah, six, seven.
Wait, but
It
it
should be
asks
seven,
which
right?
path does it terminate? So it's just. Wait,
Hold
why are
on,
we
you
counting?
because then you like draw it on the thing. Hold on, watch this. So like this is the first one. Hold on, watch this. One, two. Okay, you can't follow my thing live, but then three, and then like because the slope is like close enough to one, we can just assume that it's like the problem's not like absurdly mean and like skip a wall, you know? and then it's just like 1, 2, 3, 4, 5, 6, 7. Right? Oh wait, no, hits the wall one more time. I'm dumb. I'm dumb. I'm dumb. I'm dumb. I'm dumb. Okay, 1, 2, 3, 4, 5, 6, 7 time hitting the wall, and then this is the eighth and ninth line, right?
I thought because we got that A is 5 and B is 4, it goes 5 this way and 4 that way, so it's boom 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 B.
Wait, what is?
Wait, is the answer B? Can I check if the answer is B?
Wait, I think the answer is D though.
Why is it D?
Wait, what are you doing? I'm confused. I don't understand what you're doing.
Because like from our equations we found that oh it's gonna go x is 20 and y is 16 if we start from like if we say that we're starting from here like this is our A B C D our starting one and this is like our origin and then this P line goes up all the way this way and then we go 5 squares that way and 4 squares up. So then if we draw the picture like 5 squares that way 4 squares up.
Okay, I'm really
I
confused.
think.
I think it's D. She thinks it's
Okay,
D.
let's check.
Bro, what is
Yes,
this?
yes, yes, yes.
I'm so mad. Wait, I don't understand. Wait, can you explain this to me one more time?
Because like what we were doing here when we were getting the equation, it was like when we're extending the line, right?
Yeah,
And
yeah.
so we need it to be a multiple of 4, like both of them are a multiple of 4 in order to make it hit a vertex. And so from here we found like, oh, if x's are 4a and b's are, or y's are 4b, and then our b is 4 and our a is 5. So it's like we have 4 boxes vertically and 5 boxes horizontally.
Hold on. Wait, okay. Wait, can you go back to your other diagram thingy?
Yeah,
I
and
was
so
low
if
key
this,
like
if we
set.
start here and we go 5 boxes horizontal and 4 boxes up, that is when it hits the thing. I was
Oh,
confusing myself because I was like doing 4 and 5, but then I was thinking that we were going this way when I literally drew it like that way.
oh. Wait, but like, why isn't it D though? Still.
Because you make it towards vertex B!
No, no, but like, think about it. You have like like that could also be like considered as vertex D. You know. Okay, I'm lucky confusing myself right
I'm
now.
low-key confused too.
Because okay, so do you hear my logic? You hit 1, 2, 3, 4, 5, 6,
Oh,
7.
wait. Did I draw my thing wrong? It's because, okay, wait. Because this is gonna be D,
Dude,
and
I'm
this
getting
is gonna...
I'm getting Luke stop losing aura comments in the chat. I
Because
think
this
I'm
is
gonna stop.
ABA, and this is right? And this is ABA. So this is DC, because is that not how the grid works? So it's A, B, A,
Wait, I think you might just
B.
be like a lot smarter than me, bro.
I thought like when you extend the grid, it like makes the pattern where like the things alternate. It's like A,
Oh,
B, A, B, A,
oh,
and this is
oh,
DC,
oh,
DC,
oh,
because it mirrors, right? It reflects when it reflects,
oh. Okay, okay, okay.
right? 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 Because this
Yeah,
this
yeah.
goes A, B, A, B, A, B, A, B.
Oh, okay. You're intelligent. I'm not gonna lie.
It's to make up for the other problems I couldn't do, I think. Okay, guys. That was the last problem we're doing for today.
That's actually so sad, bro. I wanted to keep on going, dude. This was so much fun.
Yeah. Okay, guys. Today was a very, very chaotic live solve, but thankfully we had you guys here with us to help us out with a few parts, and you guys made this live solve super, super fun. Hopefully
Yes.
you enjoyed tuning in.
I enjoyed tuning in, so yeah. But I mean, we got done with the problem 17 minutes early, so like, what can I say? I think we did pretty well.
Really? Wait, I thought it ended at 9:30.
No, it's 10.
Oh my
Yeah, we're done
gosh!
early. We're done early.
Wait, we're done early. That's so awesome.
Yeah. So, if you guys like this live solve, which I really hope you did, because I liked it a lot, then you guys can like go over to the Po-Shen Loh website. Maybe you could sign up for a class that you or I are taking, but it'd be really fun if you guys could do
Mhm,
something like that.
yes.
But if not, I guess we'll see you guys later, and thank you so much for coming.
Yes, thanks for watching, everyone. Bye, guys.
Bye, everybody.
Bye.